If you ever have the need to store a lot of information of the same data type, then what we've seen up to this point really doesn't work for us. Imagine that we want to store 100 individual numbers. How would we do this? Well, in my code, I would create 100 individual variables to hold that information, and you could see that this would be a real nightmare to manage later on, especially as the data starts to grow. So this is why it's important to look into arrays. So as an overview, we'll talk about arrays and their properties. We'll talk about how to create arrays, as well as how to access and modify individual elements inside of the array. And then finally, I want you to draw this relationship between loops and arrays, especially working with the length property and any of these basic kind of operations that we have to do, like initializing an array or searching an array. So like I said before, if there's ever the case where you have a lot of information that's of the same data type, then it's a good time to use an array. And because it's all of the same data type, we say that arrays are homogeneous. Also, arrays are based on a slot number, and we're going to call that an index number. Arrays also provide us instant access to individual elements. And what do I mean by this? Well, it's not necessary to search the entire data structure here of the array to find something under certain contexts. We'll talk about that more a little bit later. The arrays are also contiguous in memory, meaning that they're stuck one right after another. And also, this is a downside, arrays are static in size, meaning that once we set their size, we can't change it later on. All right, now what would an array look like? Well, you can see a visualization here, and the first thing to notice is that there are 7 slots, but their index numbers are between 0 and 6. And therefore, it's really easy to be off by 1. And the reason is because we start at index 0. The second thing to notice is that the name of this array is called myArray, so we're going to be using that variable name later on as we start to access individual elements. So there's 2 different ways that we can create an array. In the first format, we do it all in one line, and it has this form right here. We would say data type and a pair of brackets, and I'll go ahead and tell you, anytime you see a pair of brackets, that usually means in most languages that you're working with an array. After that, we have the name of the variable that we're trying to create, gets a new data type, and this would be the same data type that we had before, followed by another pair of brackets, and on the inside of that, we have the number of elements that we're trying to create. In the second format down here, we actually break it across 2 different lines, and this is good when we don't know exactly how big of an array we need for, let's say, in the future. So in this example, we have data type bracket bracket, and then we have the variable name right here followed by a semicolon, and then potentially a little bit later on in the code, you could say whatever the name of the array is that you just created gets a new data type, and then we have the same thing that we had up here, a pair of brackets, and then on the inside of that, we have the number of elements that we want for this array. Now, if you remember, new is the way that we allocate memory in Java. So new is going to bring this thing to life. And then notice that we can create an array of any data type that we want just by changing that data type. So let's see a couple of examples. In the first example, we have an array of shorts. So I might say something like this. Short, bracket, bracket, SumArray. So the name of the array is SumArray. Gets a new short, bracket 50, bracket with a semicolon here. And this means that we have 50 slots labeled 0 through 49. In the next example down here, we have an array of strings. So I could say string bracket bracket myArray gets a new string 25. So we're trying to create 25 strings here. An array of booleans would look like this. Boolean bracket bracket list gets a new boolean 65. I think you can see the pattern here. Here's another example. Char bracket bracket characters gets a new char 255. But you can see that they all follow this template that we were talking about before of data type, and then we've got a pair of brackets, we have the variable name, and then we do the rest of the code. All right, now how would we modify an array? Well, first of all, we have to specify which slot we're putting information into. So let's look at an example, because I'm also going to point out things that I've seen people who are new to programming do that actually doesn't work. So in this example right here, I could say int bracket bracket myArray gets a new int 50. So I have 50 slots over here, 0 through 49. And then I would say myArray of 3 gets a 12. So what are we doing here? We're taking the value, the literal value, 12, and we're putting it into slot 3, which is actually the 4th slot, right? Because here's the first slot, second slot, third slot, and then the 4th slot is right here. So this is the proper way that you would put new data into the array. Now, a common mistake that I see new programmers make is something kind of like this. You would say int bracket bracket myArray gets a new int 50, and that's perfectly fine. But then a new programmer might say myArray gets 12. Now, the question is, where does the 12 go? You might think that a 12 gets copied into all slots, but that's really not what happens. So remember, the data type on the left of the equal side is an array, right? My array is an array. And the data type on the right side of the equal sign is an int. And therefore, this isn't allowed. You can't put an int into an array. You have to specify the slot like we saw right up here. Okay, now we could also access information or read information out of a particular slot. And here's an example. Assume that we have my array and that's still a valid array. We might say int client age, so we create a variable to hold the information. And then you could say client age gets my array slot 4, which is actually the 5th slot. Now when we bring an array to life, they do have default values that are on the inside of an array. All numbers, such as an int or a float, are going to be the value 0. Characters are going to be this special escape sequence of /u and then 4 zeros after that. Don't even really worry about what that means. Booleans are all going to be false, and then any complex data types like classes or something like that are all going to be null. Now we have a couple of different ways that we can initialize an array, but you initialize an array when you're unhappy with the default values that are there. So if the arrays are really small, we can use a special way to initialize the arrays using this pair of curly braces like you see right here. In other words, we're not going to use the new keyword, and the size of the array is actually going to be determined by the list that's inside those curly brackets. So let's see an example of that. If you look right here, int bracket bracket mylist, so we're going to declare an array called mylist, and then we immediately assign it the values that are going to be on the inside of it. So in this case, 9 is going to go into slot 0, 42 is going to go into slot 1, 7 is going to go into slot 2, and so on. Also notice that the list has a size of 4, and again, the index range is going to be between 0 and 3. All right, now for most arrays, especially large arrays, you're going to use a loop to initialize it. So this is the relationship that I was talking about between loops and arrays. So the problem is, let's say that we have to create an array of 5 bytes and fill each slot with the number 42. There's a reason that I limited it to 5 bytes, and it's just so we can visualize what's going on, but you could just as well do this with 5 million bytes. Okay, so here's the solution on how we would do that. In this first line, we would create an array of bytes called mylist, and we would have 5 bytes that are on the inside of that, and then we would have this loop. Now, let's walk through this and see actually what's going on. So line by line, when we create this array, it does kind of what you would imagine internally in terms of memory, that we have 5 slots, they're all initialized to 0, and the indices are 0 through 4. Now, we typically, like I said, use a loop to traverse through this, and we're going to put a 42 in each slot that you see here. So we create a counter on the inside of our for loop, and it starts out at 0. And notice that the counter is going to be used not only to tell us how many times we've gone through the loop, but it's also going to act as our index number telling us which slot we're putting information into. All right, so the counter currently is at 0. So long as the counter is less than 5, in this case it is, so what are we going to do? We'll say my list of counter gets a 42. So it's crucial that you understand what's going on here. My list is this whole array that's down here on the bottom. Counter's value currently is 0, so we're referring to slot 0, which is our first slot right here. Now what are we going to do? We're going to take a 42 and we're going to copy it into that slot. And you can see that's exactly what happened right here. Now we're at the bottom of this loop, so we go back to the top and we increment our counter by 1. You can see that 1 is still less than 5, so what are we going to do? My list of counter, and counter is now 1, so we're talking about now the second slot, which is index 1. We're going to take the 42 and put it here into that slot. We do the same thing, counter plus plus. 2 is less than 5, so what are we going to do? The same thing that we did before. My list of 2 is going to get a 42. Go back to the top of the loop, counter plus plus, counter is now 3. Is 3 less than 5? Yes, it is. So my list of 3 gets a 42. We go back to the top again, increment our counter. 4 is less than 5, so now we're talking about my list of 4 gets a 42. And then to finish it out, of course, we're going to go back. Counter plus plus counter is now 5, so this test to continue is now going to be false, and we're finished with that loop. But the end result of this is that you can see that we've iterated across each slot here, and we put a 42 manually into each slot. So the next thing that we're going to look at is how to find the smallest element. So imagine that you have an array of, let's say, 100 numbers, and they're all random numbers. Chances are you would scan the entire list, All right, so you'd go through this entire list and then you would keep track of the smallest thing that you've seen so far. So realize that computers can only compare two things at a time, so we have to code this up so that it's a step-by-step process. So again, let's assume that we have an array of only 5 ints, and the array contains random unknown numbers. They can be positive or negative, and the name of the array is called random array. So let's trace through this code right here so you can see how it is that we could work on something that has random data. Now, in this first line, you can see that we've created a variable called smallest so far, and it's of type int. And then notice in the next line down that smallest so far gets assigned whatever's in the 0th slot, or whatever's in the first slot. So that's the value 42. Okay, so we put the 42 into the smallest thing that we've seen so far because it is the smallest thing we've seen so far. And then we start our loop at slot 1. Now, why didn't we start it at 0? Well, we've already checked 0, so we might as well start iterating through the array from slot 1 to the very end. So is 1 less than 5? It is. So what are we going to do? We're going to do a comparison of the smallest thing that we've seen so far with the current slot that we're looking at. So we're doing a comparison with this 42 compared to whatever's in slot 1 right here. And you can see that's a 17. So is 42 greater than 17? If it is, then what are we going to do? We're going to update the smallest thing that we've seen so far to be the 17. So I'm going to copy out of that slot, random array of counter. Counter is 1, so I'm going to copy a 17 into the smallest thing that we've seen so far. All right, so we go back up to the top of the loop, increment the counter again. 2 is less than 5. So again, we do this comparison of the smallest thing that we've seen so far versus the slot that we're looking at. So now we have a 17 as the smallest thing so far. So we're really saying, is 17 greater than 42? Why a 42? Because remember, counter is 2. So we're talking about slot 2, random array of counter. So that's not true, so we can skip that. We'll go back up and increment our counter once again. Is 3 less than 5? Yes, it is. So again, we do a comparison with the slot that we're looking at with the smallest thing that we've seen so far. Now this is a little bit interesting because the smallest thing we've seen so far is 17, and we're comparing that with random array of counter. And here's our random array, slot 3 now we're talking about, and that's a -8. So is 17 greater than -8? Yes, it is. So we're going to update the smallest thing that we've seen so far to be whatever slot that we're looking at. In this case, it was slot 3. And so now smallest thing so far is a -8. Now you may be tempted to say, hey, we found our solution. We know that the -8 is the smallest thing that we've seen in this array, and that it is the smallest thing that we've seen in the array. However, the computer continues on searching the rest of the array until it hits the very end, right? Because it doesn't know what else is out there. It hasn't seen it yet. So we go back to the top of the loop again. Counter plus plus, counter is now 4, and 4 is less than 5. So what are we going to do? We'll say, is the smallest thing so far, -8, greater than whatever slot we're looking at? And here you can see we're on slot 4, so we're going to do a comparison between -8 and 4. And this is false, so what are we going to do? We finish that out. We now increment the counter one last time. This thing now becomes false. 5 is not less than 5, and you can see that we found the smallest element so far is -8. All right, so in summary, first of all, you need to understand that arrays hold values that are all of the same type. You can't mix a character, let's say, with ints and Java dogs and all these other kinds of things. You want your arrays to be all of the same data type. Second, creating arrays always follows a format that you should probably just go ahead and memorize. You know it'll probably be on an exam, but realistically, this is going to be something that you're doing every day for the rest of your life as a programmer. You can create an array of any type, so you could create an array of Java dogs or strings or characters. It doesn't really matter. To initialize or search arrays, most often you're going to use a loop. And remember, I wanted you to draw this relationship between the loops and the arrays, and hopefully you see that now. And then finally, arrays are going to have default values inside based on the data type of the array. Typically, these things go to 0. So that's it for arrays. Hopefully you have a better understanding of why we need them, how to create them, and how to search them.